In this video, I'm going to review the final targets in Chapter 2, making this the Chapter 2 review video Part 2. We learned how to convert fractions to decimals during Lesson 2.6. To convert a fraction to a decimal, there's a few things you can do. You might have it memorized, maybe you remember some slick tricks. You might have a calculator in your hand, in which case sometimes you can just divide, because 7 over 12 is 7 divided by 12, because the fraction bar is a division symbol. So I could take a calculator and do 7 divided by 12, or you might have to divide the 7 by 12 by hand. The directions might ask you to show your work. In this case, it's 7 divided by 12. So I'm going to divide 7 by 12. 7 goes in the shed and the 12 is on the outside. 12 does not go into 7, so I know I'm dealing with a decimal, so I need to add a decimal place and bring it up. 12 goes into 7 0 times. So I add a decimal place and add a 0. 12 goes into 70 6 times. 6 times 12 would be 72, so not 6 times. 5 times 12 would be 60, so it goes in 5 times. 5 times 12 is 60. 70 minus 60 is 10, or 7 minus 6 is 1. But 70 minus 60 is 10. 12 does not go into 10, so I'm going to add a 0 and bring it down. 12 goes into 100. 8 times 12 would be 80 plus 16, 96. 8 times 12 is 96, so it goes in 8 times. 100 minus 96 is 4. Again, I need to add one more 0, bring it down. 12 goes into 40. 3 times 12 is 36, so 3 times 36. 40 minus 36 is 4, so again I have a remainder of 4. 12 times 3 is 36, so it's going to be another 3, and then the remainder will again be 4. So that tells me something special about this number. It's not going to end, it's going to be a repeating decimal. So what's repeating is the 3. So my answer to 7/12 would be 0.583 with a repeating 3. If they wanted the number rounded to the nearest thousands place, I'm going to do my rounding here using the next digit, which is a 3. So if I wanted to give this answer rounded to the nearest thousands place, tenths, hundredths, thousandths, it would be 0.583. So 5/9. For 5/9, it is a slick trick, and you might recall what this trick was for ninths. But if I didn't know, again, I could take a calculator and do 5 divided by 9. Or I can divide 9 into 5. 9 does not go into 5, so I'm adding a decimal place. But it does go into 50. 9 times 5 is 45. 50 minus 45 is 5. The remainder is 5. Bring down a 0, it's 50 again. 9 goes into 50 5 times. And it's 50 minus 45 is 5. So the remainder again is 5. That tells me something about this number, that if I keep going, the 5 is just going to keep reappearing. So it's 0.5 repeating, or 55 repeating, or 5 repeating, but it's 0.55. And you might remember that 5/9, it's a ninth, and the slick trick for ninths was times 11. The target in this lesson was to be able to convert back and forth between fractions and decimals. So now we're going to take a look at how to convert a decimal back to a fraction. To do this, we need to understand place value. If I have a decimal with places, let's say I had this many places, remembering the places, this would be the ones place, and now we're talking about the decimal places. This would be the tenths place, the hundredths place, the thousandths place, and the 10,000ths place. Because to convert a decimal back to a fraction, you simply have to read it. 0.25 does not help me convert this back to a fraction. But if I read it using place value, the 5 is in the hundredths place. And the way we speak 0.25 is with the place value that the decimal terminates in. It's 25 and it ends in the 100th place. So it's 25 100ths. And this can be reduced to lower terms because 25 goes into itself and 100. 25 100ths is 1/4. And you probably could have seen that right away up front because 0.25 is a quarter or 25 cents. Let's try the next one, 0.04. The 4 is in what place? Well, tenths, hundredths. The 4 is in the hundredths place, so it's 4 100ths. And 4 goes into 100 25 times, and into itself once. 100 divided by 4 is 25, so the answer, final answer in lowest terms is 1/25. The last one, it's important to remember what role the decimal plays in speaking a decimal. It's 1.032, or it's 1 and some fraction. So it's going to be 1 whole and 32, and the 2 is in the tenths, hundredths, thousandths place. So it's 1 and 32 1,000ths. And 32 1,000ths can be reduced because I see they're both divisible by 2. So 1 and 16 500ths. I can keep going though because 16 and 500 are both again divisible by 2. 1 and 8 over 250. I'm just dividing by 2 until I get to lowest terms. I can divide by 2 again. 1 and 4 over 125. And unless 125 is divisible by 4 or 2, I think I'm done. And 125 is not divisible by 2, so that's my lowest answer in lowest terms. We practiced some of the slick tricks to recall from memory decimals and their fractions. So one good trick is just to remember equivalent fractions. All these fractions are equivalent. We know 1/2 is 0.5. So that means we know 2/4, we know 3/6, we know 4/8, and we know 5/10. Because they're all reducible. You can reduce them all to 1/2. They're all 0.5. Here's a couple of them that we tried remembering or practicing. Tenths and fifths. 1/10 is a dime. A tenth of a dollar is 10 cents. I like to think about money often when I'm thinking about slick tricks because it's easy to think about the amount of money you have. It's a part of a dollar. Every time you have pocket change, you have a fraction of a dollar. So if you had 2 dimes in your pocket, how much money would you have? You'd have 20 cents. So it's 0.2. 3/5 and 4/5 can easily be rewritten as tenths. So 3/5, if I rewrite it as an equal fraction to 3/5 by multiplying it by 2, is 6/10. And 6/10 is 6 dimes or 0.6. 4/5 is 8/10. And since tenths are dimes, 8/10 is 80 cents. But fifths go up by 20. So I wanted that to be a fifth. Fifths go up by 0.2. Every fifth of a dollar is 20 cents. 1/5 is 20, 2/5 is 40, 3/5 is 60. Tenths go up by dimes. Eighths was one of the hardest ones, but there's some equivalent fractions in eighths because 2/8 is a quarter. If I reduce it by dividing the top and the bottom by 2, I get a quarter, and a quarter is 0.25. Well, 1/8 is half of 2/8. This is how we rationalized 1/8. So what's half of a quarter? So we took a quarter, I gave you 25 pennies, and we divided it up. And there were 12 pennies in each pile, and then there was a penny left. That's how we got 0.125. All eighths end in 5, and 1/8 is half of a quarter. So 5/8 is one more eighth than 4/8. 4/8 is 50 cents. So if I add 50 cents plus 12.125 cents, I would have 0.625. So hopefully you can remember some of these. Eighths is a hard one. 6/9. The trick for ninths was times 11. And the trick for 11th was times 9. They're reversed. So 6/9 is 6 times 11, is 66. They're all repeating. And 7/9 is 7 times 11, it's 77, and they're all repeating. The 11ths were just the opposite. 3/11ths is 3 times 9, is 27. It's 0.27. And they're repeating, it's 27, 27, 27. And 7/11ths was 7 times 9. 7 times 9 is 63, and it was 63 repeating. So hopefully you can recall some from memory, decimals for fraction equivalents. Okay, the last two targets were about comparing and ordering fractions and decimals. You might be asked to compare a group of numbers or two numbers using the inequality symbols greater than, less than, greater than equal to, or less than equal to. Remember, the Pac-Man wants to eat the bigger number. It's always going to be directed, the open mouth is always going to be directed towards the larger number. So here's the challenge. It's pretty hard to compare 3/8 to 0.3 repeating because they're different types of numbers. The easiest way to do this is to try to write each number in the same form, like converting 3/8 to a decimal. 3/8, take a calculator and divide 3 by 8, or divide 8 into 3, or remember it from Slick Tricks. 3/8 is 0.375. So if I want to compare 0.375 to 0.3 repeating, it's a repeating 3. Sometimes it's helpful to stack the numbers up and look at the place values. This one has a 7. The other one has a 3. So it's telling me this number is larger than this number. So 3/8 is greater than 0.3 repeating. To compare 1.57 to 1 5/9, I would need to convert 1 5/9 to a decimal. Well, 5/9, it's a ninth. So if I multiply the numerator times 11, it becomes 1.55. So if I'm comparing 1.55 to 1.57, I can see that 1.57 is greater than 1 5/9 because it has a 7 in the hundreds place. Another big part of the target with comparing and ordering fractions and decimals is to be able to order multiple fractions and decimals. The challenge here is that sometimes when you're trying to order fractions or order three numbers like these three numbers, they're not all in the same form. Notice you have two that are written as fractions and one that's written as a decimal. That's kind of hard to compare. The easiest way to do this would be to convert them all to the same form, like convert them all to decimals. So 1 2/7, 1.31 and 1 1/3. We're always going to be ordering them from least to greatest, from smallest to largest, like as if you were putting them on a number line. 1 2/7, that's a hard one, so you might need to take a calculator and convert the 2/7 part to a decimal, because it's going to be 1 point something. So we want to figure out what 2/7 is. It's 1 and 2/7, so it's 1 point something. Well, I know 2/7 is 2/8. From Slick Tricks, it's 1.28. And 1.31 is 1.31. And 1 1/3 is going to be 1 point something. And 1/3 is 3 repeating. So we'll give it a couple threes. It's like 1.333. So now I need to compare these three decimals to figure out which one's the smallest. Well, it's actually kind of in order that 1 2/7 is the smallest, because it's $1.28. So if I think about this in terms of money, this is $1.28. This is $1.31. This is $1.33. So I actually had them in order already. That's by accident. But that's that number set in order from least to greatest. You're also going to have to compare fractions and decimals that have negatives. As long as we remember that on a number line, from 0, the further to the left you go, the smaller the number. So we actually will look for the largest number, and since it's negative, it will be the smallest number. But let's first convert. Negative 0.246 is already a decimal. 3/8. 3/8 as a decimal. All 8s end in 5. 2/8 is 25. So if I add 12 cents to that, I get 37. So it's negative 0.37, and that ends in 5. Negative 4/11ths. 4/11ths, the slick trick is times 9. Remember, you can always take a calculator and do 4 divided by 11. Or, by hand, divide 4 by 11. But 9 times 4 is 36. So it's negative 0.36. And the 36 is repeating because it's an 11th. So let's stack these numbers up on top of each other, which is a good strategy for comparing decimals. They all have a 0 in the ones place. These two both have 3 in the tens place, and this one has a 2. So what does that mean? Since they're all negative, this one has a 2. It means this number is actually the closest to 0, making it the largest. So negative 0.246 would be the largest number in the group. So we need to decide which one of these two numbers is going to be the smallest. Well, they both have a 3 in the tens place. This one has a 7. This one has a 6. The 7 makes 3/8 a bigger number that's negative. So the negative 3/8 would actually be the smallest number. And the middle one is negative 4/11ths. And the largest one is negative 0.246. That's pretty tough. Lastly, I'm going to give you some problems to try. But before I forget, let me just tell you how to find the secret code word for today. When you walk into class today, if you go up to the front of the room and look at the wolf, the magnetized wolf to the board, the wolf's going to have a word written on the board underneath him. If you can find that word and then come up to me and tell me what the secret code word is, I have a special treat for you. Remember, look on the front of the room near the wolf to find the code word. So you try. Click pause and solve these problems. There are 7 problems this time. So get out your notebook, copy each problem, and try solving them. And when you're done, I'll go over them. Just click play, and I'll solve each one, and you can check your answers as you go. So click pause and give these 7 problems a try. Okay, number 1, 5/12. I don't know what 5/12 would be as a slick trick, so I could take a calculator and divide 5 by 12. But I'm going to ask you on the final chapter test to show your work. If it says show your work, you need to do 12 divided into 5. And in this case, I know I have to add a 0 and a decimal because 12 doesn't go into 5. But 12 does go into 50. 4 times 12 is 48. 50 minus 48 is 2. I have to bring down another 0 because 12 does not go into 2. 12 goes into 20 one time. 20 minus 12 is 8. 12 does not go into 8, so I have to bring down another 0. 12 goes into 80. 6 times 12 would be 72. 6 times. And 80 minus 72 is 8 again. So here I have another remainder of 8. And if I bring down another 0, run out of room here, it's 80 again. So it's going to be another 6. So it's 0.416 repeating. So 5/12 is 0.416 repeating 6. One in 5/6 is going to be a decimal with 1 point something. Well, I know 5/6 from Slick Tricks, it's an approximation is 84. But I could do 5 divided by 6 on a calculator, and I would get 83 repeating. From Slick Tricks, I know 5/6, but it's going to be 1 point something. So you should have somewhere around 1.84 or 1.83. Number 3, convert to a fraction. Change the color. Convert 0.036 to a fraction. Remember, you have to read the place value of the last digit. The 6 is in the tenths, hundredths, thousandths place. So it's going to be 36 1,000ths, which can be reduced to 18 500ths, which can be reduced again to 9 over 250,
Oops, that's a 9. And 9 is only divisible by 9 and 3, so 3 does not go into 250. So that's it. 9 over 250. Reduced. Number 4, 1.15. It's going to be 1 and some fraction. So this is a 5 in the hundredths place. So it's 15 100ths, which can be reduced to 1, and they're both divisible by 5. 15 divided by 5 is 3. So 1 and 3, 100 divided by 5 is 20. 1 and 3/20ths would be a good answer in lowest terms. Number 5, 1.132 compared to 1.1313, repeating 13. So I'm running out of space, but I'm going to stack them up on top of each other. 1.132 and 1.13 repeating, so it would be a 1 there. So this one's hard. They both have a 1 in the ones place, a 1 in the tenths place, a 3 in the hundredths place, but this one has a 2 compared to the 1 in the other place. So 1.132 is just slightly larger, so that it'd be a greater than symbol. 2 1/3 is 2.3 repeating, and 2 3/10 is 2.6 repeating. Sorry, just 2.6. So no, 3/10. Let me back that up. 3/10 is 30, so it's 2.3. Okay, so 2.3 repeating and 2.3. That makes more sense. Well, this one has a repeating 3. This one has a terminating decimal, so it would have a 0 in the next place. So 2 1/3 would be just bigger. 2.3333 versus 2.3 would be larger. So greater than again. And the last question, order these numbers from least to greatest. I'd have to rewrite them all as decimals. So 2.4 is already a decimal. 2.35, 2 3/5 is 3/5. Fifths go up by 20 is 2.6. And 2 5/9, it's a ninth, so I know it's times 11, so it's 2.55. So the smallest number would be $2.40 or 2.4. The next one up would be $2.55 or 2.55, which is 2 5/9. Don't need the decimal there. And the last one would be 2 3/5. So from least to greatest, 2.4, 2 5/9, and then 2 3/5. So check your answers, mark them all, X's and C's. How'd you do?